Algebra 2, we're still on the same sheet as yesterday, chapters 5 through 8 sheet. Just today, or maybe it's 5 through 7. Just today we're starting at 29 and going to the end. So 29, you can just drop all the parentheses and combine like terms. -4 plus 9 makes 5, and keep the a squared there. The +5, +8 is +13, keep the a there, and the numbers make a -13. 30 is a little different. The 5x plus 6, you can drop the parentheses when there's nothing in front of them. But for the second half, with the 7x minus 8, the minus has to switch all those signs. So the 7 takes on that minus, the -8 turns into a plus. And then we combine like terms. 5 minus 7 is -2 for the x's. The numbers tack on a +14. 31, we're just distributing. 3 multiplies each number, so 4, 5, 6 become 12, 15, and 18. And then you'll add the powers. 4 plus 2 is 6 for the first one, 4 plus 1 is 5 for the second one, and after the fourth just tacks on to the third one. 32, we're foiling. Foiling was an acronym where the F stood for multiplying the firsts, which is x squared. The O stood for the outsides, which is a 4x. The I stood for the insides, which is a 5x. And the L stood for the lasts, which is a 20. And then those are like terms, we want to combine those into a 9x. 33, same thing, just FOIL. I wrote the steps on the key if you want to see the in-between steps and the answers, they're there. 34, same thing basically. If you do a few problems in your life like 34, you soon realize you can shortcut that because there's going to be opposites that eliminate. 35, you can copy the square, 2 of them side by side, and just do the same thing. Or you can memorize a pattern. Take the x times itself, copy the sign, double the 4 to get an 8, put an x, always put a plus, and 4 times 4 is 16. That'll always be a pattern that works for squaring. 36 is just doing a factor tree, so I made you a tree on the paper. You can see that. 37, I made another tree. Remember the rule for 3. Add up the digits. And since the digits add up to 3, 3 can go in. Those rules for 2s, 3s, 4s, 6s, those kind of rules can sometimes help you do the trees. 38, we're looking for the biggest number that goes into both. 24 will be it. There's lots of numbers that go into both. Maybe you want to make a list of everything that goes into both. You want the biggest thing that goes into both, and that's 24. 39, we're factoring. If you need a super in-depth thing about factoring, go ahead and watch the first Algebra 1 video I ever made. The first Algebra 1 video I ever made was a review on all the factoring things, and that would be a nice review from 39 for a while if you need more detail than this video has. But the first thing you look for is a GCF. 12 and 4, 4 is the biggest number that goes into both. With x's, you take the lower power. With y's, you take the lower power, and the GCF goes in front. And then we're dividing everything by that. So 12 dividing 4 is 3, 4 dividing 4 is a 1 that I don't have to write. x3, we took off 2 of them, that leaves an x. y3, we took off a y, that leaves 2 of them. Here we took everything off, so actually I do need to write that 1. A lot of times we can do an invisible 1, but this time, since there's nothing else there, we need that to be a visible 1. 40, we're factoring now a thing called trinomials. There's 3 terms. We're going to make 2 sets of parentheses called factors. With x squared, we'll start x and x. If there's a plus, that always told us that these signs have to be the same, and they have to be the same as the original sign, so both pluses here. And when the signs are the same, we add to make the middle from times table numbers that can multiply to make 12. 6 and 2 will do that trick. For 41, the last sign is a minus, so that makes these different. And then we subtract to make the middle, but we're always multiplying to make the end. 4 and 3 would do that job. This sign will take the bigger number when they're different. So 4 and 3 that way. 42 is like 41. The signs are different, the minus sign will take the bigger number. 43 is one where we have to guess. With 2x squared, there's not much of a guess, it's 2x and x. With the minus, the signs are going to be different, so we just guess which one's plus and which one's minus, and we hope for the best. With 5, it's 5 times 1, but we just try to guess where the 5 is and where the 1 is. And we probably don't guess right. You have to FOIL to check your guess. Multiplying these makes negative 10. Multiplying these is positive 1. Negative 10 combined with positive 1 is not a negative 3. So I need to change some stuff. So let me start by swapping the 5 and the 1. Now this is a positive 5, this is a negative 2. Positive 5 and negative 2 is a positive 3, but I want a negative 3. So I need to swap the signs, and now that'll be good. 44 was a problem called a difference of squares. So you make two almost matches, one with plus, one with minus. You cut the power in half to have x's, you root the number to have 7's, and you just make the signs be different. 45, you could try to do like 40 and follow the rules for the signs, but you're going to end up with two perfect matches, so write it as a square, x minus 5 squared. 46, when there's 4 items, we do a thing called factor by grouping. And recognize there's an a in common to this first group that we can take off, leaving an x and a 1. There's a b in common to the next group, which we can take off, leaving an x and a 1. When these are a match, that's a sign you're headed in a good direction. The answer will have that matching thing, as well as the non-matching stuff to make another factor. The a plus the b that are there, that becomes your outer group. 47, the equation has to be equal to 0, which it is. Then you want a factor, which I did for you. And then you just look to the parentheses and flop the signs. Negative 5 is an answer, because that would make one of the pieces of the problem 0. Positive 4 is the other answer. 48, same theme, but more work, because it's not equal to 0, it's equal to 10. So you have to do an opposite to eliminate the 10. Since it's positive, subtract the 10, and that changes both sides. Then you have to factor by yourself x with a minus. Signs are different. When they're different, we subtract to 9. 10 times 1 would be a pair of numbers that do that. The minus takes the bigger one, which is the 10, and that's the 1. And then we just flop signs. If this were negative 1, we'd make that part of the problem 0, which is what we want. Positive 10 minus 10 makes that part of the problem 0, which is what we want. So positive 10 and negative 1 are those answers. 49, I would suggest a picture anytime they start talking about shapes. The one side is 7 more. So do an x plus 7 versus an x. We're doing an area, so I don't need to label those sides, because area just multiplies 2 of them. So if you write a distribute problem that equal to 170, you're good for the first blank. I would then distribute, and we want these problems to equal 0 like we did a moment ago. To get 170 out of there, I'd have to subtract 170, and then factor. With a minus, signs are different. Multiplying to 170 and subtracting to 7 would be 10 with 17. 10 with 17, multiply and subtract to make the numbers we need. Plus takes the bigger number. This tells me a 10. This tells me a negative 17. Shapes can't have negative 17 sides. But if this is 10, the other side, 7 more, is positive 17. You might remember a lot of times the answer we killed off kept managing to resurrect itself on the picture again, and that's a sign that you did something good. 50, we're doing consecutive integers, so we've always named those x and x plus 1. That was on the last review sheet, and it's back again. If this were an even number or an odd number, this would be a 2 instead. We want to multiply those. Product means multiply is 420. So if you put that in the first blank, we're good. Distribute. we like everything to equal 0 on this whole page, so I could subtract the 420 to make that equal 0. And then I'd like to factor. With a minus, these signs are different. And when they're different, we want to subtract to make the middle, which is 1. There's a lot of numbers that go into 420. But if they're going to subtract to make 1, they need to be close together. So use your calculator, trial and error. Eventually you'll stumble your way into the fact that 20 goes into that 21 times. And those subtract to make 1. Plus takes the bigger number, minus takes the other number. This tells us that negative 21 could be an answer, and there's no reason to throw away a negative on this one. This tells me that 20 could be an answer, but we want to have a list of 2. The number next above 20 is 21. The number next above negative 21 is negative 20. Think about the number line counting up from negative 21 gets you to negative 20. And that's that sheet. So next time you have an algebra day, you're looking to do this, this test as a test, feel free to use the video, the sheet I sent you, your own sheets, all of your materials to make the best product you can make.